Humanity's most enduring monument was never built of stone or steel. It was cast in polyethylene and polypropylene. Long after our cities fractured into sediment and memory, our refuse remained, floating in slow, endless gyres across silent oceans. The archive confirms that nature did not choke on this legacy. It adapted. It learned to feed on what we believed eternal. This is the record of the Plastivores, the first lineage of life to bridge organic metabolism and synthetic chemistry. By the year 2 million after human departure, the North Pacific accumulation had transformed. No longer a drifting patch, but a compressed continent of polymer strata. A floating geological formation built entirely from discarded materials. Storm systems press against its edges. Ocean currents grind its surface. Yet the structure persists, flexing, shifting, regenerating. Here, evolution accelerated under chemical pressure. Radiation, toxicity, and scarcity reshaped selection itself. Only organisms capable of extracting energy from artificial compounds survived. The foundation species is Plastivora corallium, a reef organism that no longer harvests sunlight. Instead, it secretes specialized enzymes capable of cleaving long-chain hydrocarbons. Plastic is not shelter. Plastic is nutrient. Energy is extracted from molecular bonds we once engineered for permanence. At microscopic scale, polymer chains are disassembled into usable carbon fragments. Waste becomes metabolic fuel. Decay is replaced by digestion. Its skeletal structures are not mineral. They are braided fibers of recycled nylon and synthetic composites. Harvested from ancient fishing nets and industrial polymers, structural strength is achieved through tensile weave, not calcification. The reef grows not upward from stone, but outward from debris. Architecture born from waste. Within this synthetic forest, new food webs emerged. Filter feeders strain microplastics as plankton. Scavengers metabolize dissolved polymers, drifting in thermal currents. Colonies expand by binding loose debris into fresh growth platforms. Entire habitats migrate with the tides. Every organism here carries fragments of humanity in its tissues. Our civilization reduced to digestible chemistry. But where ecosystems rise, predators follow. The archive identifies the apex hunter as Synthetomanta vorax, an organism derived from the ancient ray body plan, now reshaped by polymer integration. Its skin is not skin. It is layered composite tissue, organic muscle woven through microplastic fibers, translucent synthetic membranes insulating a core that runs hotter than surrounding waters. Internal circulation no longer resembles blood. It is a dense petroleum-like fluid, rich in dissolved carbon compounds, fueling extreme metabolic efficiency. The body functions as both organism and refinery. Heat generated by chemical processing is retained beneath polymer insulation layers. Thermal gradients radiate outward, detectable by distant prey. The mouth is concealed beneath overlapping jaw plates. When feeding, these plates separate to expose jagged polymer shards, edges sharper than volcanic glass. Designed not to tear flesh, but to fracture hardened synthetic reefs. Fragments are ingested and chemically reduced within reinforced digestive chambers. Nothing is expelled unused. Touching the body of Syntheto manta vorax would not feel like muscle. It would feel like heat-soaked plastic, smooth, resilient, and wrong. Predation in this ecosystem is not frantic. The manta does not chase, it glides, massive, silent, and deliberate. Approaching polymer colonies until its shadow alone triggers structural collapse. Then feeding begins. Even defensive structures fail under sustained mechanical pressure. Entire reef segments can be reduced to drifting particulate within minutes. Every movement is optimized for energy conservation. Every organ tuned for chemical processing. This is not survival. This is industrial-grade biology. Core samples recovered from this era reveal the long-term consequence. A stratigraphic boundary known as the techno-fossil horizon. A 2-meter layer of compressed neon sediments, where plastivore remains are fused with consumer artifacts. Packaging, fragments of devices, synthetic textiles, all bonded into permanent geological record. Future geologists will not identify this layer as extinction. They will classify it as transformation. An epoch where manufacturing became metabolism, where industry became ecology. What has been recovered is only a fragment. The archive will continue assembling what remains,